We are going to go over the second half of the questions here, starting with question 8. What products when potassium hydroxide reacts, what are the products when potassium hydroxide reacts with hydrochloric acid? Well, potassium hydroxide, or KOH, is a base. Hydrochloric acid, HCl, obviously is an acid. If you weren't sure, of course, you could go back again and look at K and L. So we have hydrochloric acid and potassium hydroxide. An acid and a base will neutralize one another, and they form two products, a salt and water. Yeah, you know water is H2O, so that would be one of the products. And pretty quickly I can eliminate here choices 1 and choice 4. So I'm left with 2 and 3. And, well, choice 2 doesn't really make any sense. We're going to not end up with solid potassium and chlorine gas. It's going to be a salt and water. So the answer there is KCl and H2O. For a salt, remember that's a metal and a non-metal, and your water. Let's move on to question 9. So we're dealing with titration. How do I know that? Well, they're telling us that. We're given volume and the molarity of sodium hydroxide, which is a base, and it's neutralizing 24 mils of HCl, which is an acid. So here we have the math of the acid-base salt unit, and that would be for titration here. Molarity of the acid, volume of the acid, molarity of the base, volume of the base. So let's go back and let's just do the math here. My suggestion, right, let's line up the acid on one side, the base on another. Molarity of the acid, volume of the acid is equal to the molarity of the base, volume of the base, and just plug it in. So we're looking for the concentration of the acid, so that's molarity of the acid. The volume of the acid was 24 mils. As long as it's either milliliters on both sides or liters on both sides, we don't have to do any conversion there. So molarity of the base was 0.15 molar, and the volume of the base was 20 mils. So it's 0.15, I don't know if you can see the decimal there, 0.15 times 20 and divided by 24. So my molarity of my acid is the 0.125 molar, and that's choice 1. Let's move on. Okay, question 10. According to one acid-base theory, water molecule acts as an acid when the molecule. Well, we already had the similar question here in question 3. So it's showing up again. And, of course, an acid donates H+, which also sometimes your teacher might have said it was a proton. That is choice 1. Question 11. According to one acid-base theory again, water can act as a base because water can accept H+. So 3 times now, the other acid-base theory, known as Bronsted-Lowry theory, the definition of an acid or a base is showing up. Look what's showing up again in question 12. It's another titration question. Molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Look at the way it's worded. The word titration is not there, but it's telling you completely neutralizing. So once again, let me go ahead. I already have this set up. And let's fill it in. So here we're going to line up once again with the equation. So the molarity of the acid is my 0.8. My volume of the acid is 15 mils. Once again, as long as it's either milliliters on both sides or liters on both sides, we're fine. On the other side, my molarity of my base is 0.3, so I'm looking for the volume of the base. So 0.8 times 15 divided by 3, and the volume of the base is going to be 40 mils, or choice 4. Let's go on to 13. Based on Arrhenius' theory, when potassium hydroxide dissolves in water, only negative ions. So now we're back to Arrhenius' theory on a base. The only negative ions are OH minus. If he had asked about an acid, it would be the positive ions being H plus. But this is base, so this is OH minus. And then finally, for question 14, compared to distilled water, an aqueous salt solution has Again, acids, bases, and salts are all good conductors of electricity, known as electrolytes, and there it is, choice 1. So, you've been looking at the answers and the explanations for the second half of acids, bases, and salts at nychemcoach.com. Keep working hard, and good luck.